In this video, we are going to learn about mirrors. As we know that mirrors are responsible for the image formation, and this image formation is due to the phenomenon of reflection. We know reflection are of two types, regular and diffused, and in this image formation, regular reflection is involved. Now, if I ask you that if regular reflection is going to take place, what kind of surface you want? You will answer me that you want a smooth and even surface. Therefore, it is written here that a mirror is a smooth reflective surface. And what happens in reflection? That the light bounces back. So it continues its sentence like this. A mirror is a smooth reflective surface that bounces light rays back to create an image. When the light hits the mirror, it reflects back. This is what? Reflection. And this reflection allows you to see a clear image of whatever that is in front of it. Whatever means irrespective of any object. If object is there, image formation will happen. Now, how a mirror is formed? One surface of the mirror is made opaque by silvering and then by a thin coating of red lead oxide paint. Lead is actually an element and it is represented by Pb. In the diagram, in questions, whenever you want to draw a mirror, you draw a simple line, then to show the opaque surface, you make slanting lines just like this. So this is how you represent mirrors. Now let us come on the types of mirrors. Basically two types of mirrors are there. Plane mirror that is shown in this image and the second one is curved mirror that is shown in this image. So both are highly polished surfaces. Plane mirror will be highly polished plane surface and curved mirror will be highly polished curved surface. It is flat, smooth mirror that reflects light to produce a clear and upright image of an object. Generally, the surface is spherical in shape. In that case, the mirror is called a spherical mirror. As you can see in this image, this is the shape of a sphere. Hence, it will be known as curved mirror as well as spherical mirror. Now, let us come on the images formed by the mirror. So, basically, images are of two types, real and virtual. We have classified these two images, real and virtual, on the basis of meeting of reflected light. First of all, let us understand that what is image. Actually, the point where you can see that the reflected lights are meeting, this is known as image. For example, suppose there is happening a reflection. This is the reflecting surface. The beam of light is falling just like this. What will happen? It will get reflected back just like this. Now let's take second beam. This one is second and it gets reflected. Now you have to see that where the image will be formed. The image will be formed where the reflected light, or you can say reflected light rays, that I am marking with the green color will meet. So if they will continue to move forward in this direction, they will not meet. But the image formation has to be happen. Therefore, extend it backward. The point where they meet, for example, this C point. This C point will be the point of image formation. This is the point of image formation. Therefore, it is written that when the light rays is starting from a point object after reflection from a mirror meet or appear to meet at a point. Meet matlab they are actually meeting. Appear to meet, they are not actually meeting, they have been extended backward, just like in this case. So, not actually meeting. Then this point is called image of the given object point. Now let's discuss about real image and virtual image. Now what will happen that if the reflected light rays are actually meeting, are actually intersecting, then it will give rise to real image. Therefore, it is written that after reflection actually intersect each other. When the light rays actually intersect each other, it gives rise to real image. But when after the reflection, they intersect each other when extended in the backward direction, just like this case, then it gives rise to virtual image. The next point of difference is this: real image can be obtained on a screen because the lights are actually meeting. But in virtual image, as the lights is not actually meeting, then it cannot be obtained on a screen. One more thing I want to clear, that real image is always inverted. Inverted means suppose the object is in this direction, then the image formation will be in this direction. This means inversion. So real image is inverted one, but virtual image is always erect, or you can say upright. Now let's discuss about the image formed by a plane mirror. First of all, as in the case of plane mirror, the diagram which we have just discussed here, let me explain you once more for more clarity. Suppose this blue line is actually the plane mirror. What will happen? First ray will come. It will be reflected back in this direction. Second ray will also come and it will be reflected back in this direction. Now the line which I am going to highlight with yellow color are actually the reflected lights. They will not actually meet in this direction. Where they will meet? If they are extended backwards, just like this. So this is the point of image formation. As the image formation is taking place when we extend backward the lines, so it is an example of virtual image. Virtual image means it cannot be obtained on the screen, and also it will be upright or erect. So it is written here that you can conclude that a plane mirror forms an upright or erect image of an object placed in front of it. Moreover, the image is of same size as the object. You can easily observe this thing in your daily life. Now we have to perform some activities which we will discuss to know about the characteristics of image formed by the plane mirror. Our first activity is to demonstrate that the plane mirror produces lateral inversion. Lateral inversion means the object on the right will become the object kept at the left. So this is the lateral inversion. So what are the materials required for you? Whiteboard and a plane mirror. Now what you have to do is this. You have to take the white cardboard and you have to write the letter L on it. Just like this. And you have to keep this in front of the mirror. Keeping in front of the mirror, what you will observe? The image formation, and in the image formation, you will observe the L to be looking just like this. This is your left side, this is your right hand side. Here it is your left and it is your right. So what you are seeing, that the particles on the right hand side, they came on the left hand side on the image formation. So basically this is the lateral inversion.